Case study: Revolutionizing Network Security, Technova's AI-driven approach to cyber threat detection and response. Securing a company's network infrastructure is no longer a matter of choice, but of survival. At Technova, a mid-sized technology firm handling sensitive client data, the pressure to safeguard its network against evolving cyber threats is immense. The IT team, led by Chief Information Security Officer Maria Gomez, faces a daunting task: ensuring the security of the network while managing a growing volume of data and increasingly sophisticated attacks. Maria's team employs traditional methods for network traffic analysis, relying on signature-based detection systems. These methods, while useful, have limitations that leave the network susceptible to zero-day exploits and advanced persistent threats. Recognizing these deficiencies, Maria proposes a shift towards artificial intelligence-driven solutions to bolster Technova's cybersecurity posture. One of the key advantages of AI in network traffic analysis is its ability to handle vast amounts of data. Technova's network generates terabytes of data daily from various protocols and applications. Traditional systems struggle to keep up with this volume, resulting in delays in identifying and mitigating threats. How can AI overcome these limitations and improve threat detection in real time? For instance, by employing machine learning algorithms that can analyze data as it is generated, AI can provide immediate insights, enabling quicker response times. Maria's team decides to implement a deep learning-based intrusion detection system capable of real-time analysis. Early results are promising. The IDS identifies several instances of anomalous traffic patterns indicative of distributed denial-of-service attacks. The speed and accuracy of detection surpass their previous methods, raising another critical question. What makes deep learning techniques more effective for real-time threat detection compared to traditional batch processing methods? The answer lies in the continuous learning capabilities of AI models, which adapt to new threats as they emerge, significantly reducing the window of vulnerability. Anomaly detection is another area where AI proves invaluable. Technova's network had previously experienced insider threats where authenticated users abused their access rights. Traditional signature-based systems failed to detect these activities because they didn't match any known threat signatures. Maria's team implements clustering and outlier detection algorithms to identify unusual patterns that deviate from normal behavior. How do these AI algorithms distinguish between normal and abnormal traffic effectively? Clustering algorithms group similar data points together, making it easier to identify outliers that exhibit unusual characteristics. Outlier detection algorithms then flag these anomalies for further investigation. Predictive analytics offers a proactive approach to network security. By analyzing historical network data, predictive models can forecast potential threats and system inefficiencies. Technova leverages time series analysis to predict traffic patterns and identify potential bottlenecks. This foresight allows Maria's team to allocate resources more efficiently and reinforce weak points in their network defenses. How does predictive analytics enhance the overall efficiency of network security operations? By anticipating issues before they materialize, predictive models reduce false positives, enabling security teams to focus on genuine threats. Automated response systems represent another leap forward for Technova. AI-driven systems can not only detect threats, but also take immediate action to neutralize them. For example, when the IDS identifies malicious IP addresses, the system automatically blocks them, preventing further malicious activity. This automation is particularly valuable in large-scale network environments where manual intervention is impractical. What are the benefits and potential risks of relying on automated response systems in network security? While automation significantly reduces response times and minimizes the impact of attacks, it also raises concerns about the system's ability to handle complex scenarios without human oversight. However, the transition to AI-driven network traffic analysis is not without challenges. One significant issue is the quality and diversity of the training data. AI models require extensive datasets to learn effectively, and if the data is not representative of all possible network behaviors and threats, the model's performance may be compromised. Maria's team invests considerable effort in curating comprehensive and high-quality datasets. What strategies can organizations adopt to ensure the robustness and reliability of AI models despite the variability in training data? Continuous data enrichment and model retraining are essential to maintaining high performance and adapting to new threats. Ethical considerations also come to the forefront with the use of AI in network monitoring. The analysis of potentially sensitive data raises privacy concerns, and Maria is acutely aware of the need to balance security with user privacy. How can organizations implement AI-driven network monitoring while ensuring compliance with data protection regulations and maintaining user trust? Developing explainable AI models that provide transparency in decision-making processes is crucial. These models help illustrate how decisions are made, fostering trust and ensuring ethical use. Through these implementations, Teknova significantly enhances its network security posture. The integration of AI-driven solutions not only improves threat detection and response times, but also introduces a level of automation that allows Maria's team to focus on more strategic tasks. The shift from traditional methods to AI-driven network traffic analysis marks a pivotal transformation in their cybersecurity strategy. Upon reflection, Maria and her team consider several key takeaways from their experience. First, the ability of AI to process and analyze large datasets in real time is a game changer. This capability addresses the limitations of traditional batch processing methods, providing immediate insights and enabling quicker responses to threats. Second, the effectiveness of AI in anomaly detection and predictive analytics cannot be overstated. By identifying deviations from normal behavior and forecasting potential issues, AI-driven models enhance the overall efficiency of network security operations. The team also acknowledges the importance of continuous data enrichment and model retraining. Ensuring the quality and diversity of training data is crucial to maintaining the robustness and reliability of AI models. Additionally, the ethical implications of AI-driven network monitoring must be carefully managed. Transparency, accountability, and compliance with data protection regulations are essential to maintaining user trust and ensuring ethical use. In conclusion, Teknova's journey illustrates the transformative potential of AI in network traffic analysis. By leveraging AI's capabilities in real-time analysis, anomaly detection, predictive analytics, and automated response, organizations can significantly enhance their network security posture. Despite the challenges and ethical considerations, the benefits of integrating AI into network security operations are substantial, making it an indispensable tool in the arsenal of modern cybersecurity solutions.